Let's look at a specific cooling example with typical temperatures, pressures, and system components of a positive displacement vapor compression cycle. In this and the other examples in this program, temperatures are in degrees Fahrenheit, while pressures are in pounds per square inch, unless otherwise noted. This example cooling system has a positive displacement reciprocating compressor, an air-cooled condenser, and a direct expansion evaporator, sometimes called DX. The refrigerant is HCFC-22. The indoor air temperature is controlled at 75 degrees, and the outdoor air temperature is 95 degrees. In this example, we'll follow the refrigerant through an entire cycle, starting at the evaporator. The evaporator is a plate fin coil with copper tubes. The indoor air to be cooled flows between the aluminum fins and over the copper tubes, while the refrigerant flows through the copper tubes. Inside the evaporator tubes, the refrigerant pressure is held at 68.6 psig by the suction action of the compressor, which draws off the refrigerant vapor and maintains the evaporator or low side pressure. This pressure corresponds to a boiling point of 40 degrees for HCFC-22. This is called the saturated evaporating temperature. As the 40-degree liquid-vapor refrigerant mixture flows through the evaporator tubes, it picks up heat from the 75-degree indoor air. This heat transfer cools the air and causes the refrigerant to evaporate. By the time it reaches the end of the evaporator, all the refrigerant is changed from liquid to vapor. The vapor is heated an additional 10 degrees above the saturated evaporating temperature, to 50 degrees, before it leaves the evaporator. We call this added heat superheat. The compressor draws the refrigerant vapor through the suction line and compresses it. The hot, compressed refrigerant vapor discharged by the compressor flows through the discharge line and into the condenser. The compressor maintains the vapor at a high side pressure of 260 psig, which corresponds to a condensing temperature of 120 degrees for HCFC-22. This is called the saturated condensing temperature. The air-cooled condenser is a plate fin coil with copper tubes. Outdoor air flows between the aluminum fins and over the outside of the copper tubes, while the refrigerant flows through the copper tubes. As the 120-degree refrigerant vapor flows through the condenser tubes, it rejects heat to the 95-degree outdoor air and condenses into a liquid at 120 degrees. By the time it reaches the end of the condenser, all of the refrigerant vapor has condensed to a liquid, and this liquid is cooled an additional 10 degrees below the saturated condensing temperature to 110 degrees before it finally leaves the condenser. This added cooling is called subcooling. The cycle is completed as the liquid refrigerant flows through the liquid line to the metering device. In our cooling example, liquid refrigerant enters the metering device from the high side at 110 degrees and 260 psig. This device restricts the flow of refrigerant, dropping its pressure to 68.6 psig, flashing some of the liquid refrigerant to a vapor, and reducing its temperature to 40 degrees. The 40-degree liquid and vapor mixture then flows into the evaporator, where the cooling cycle can begin again. This is the positive displacement vapor compression refrigeration cooling cycle. Please take a moment to complete the following learning activity. To continue, make your selection.